the first announcement I have to make is that I changed the name of the project on Friday. I realized that there is already a Rust crate called Enclave, so to avoid the conflicts, I decided to rename it to lockc, which stands for lock container. So it's like similar name to runc, which is run container. And yeah, in general, lockc is a project written mostly in Rust, which is supposed to harden container workloads. And to start presenting the idea, I will slightly remind about the fact that containers do not contain in the way as many people think. Many people would expect that if they run containers, containers are fully isolated. They're as secure as VMs by design, which is not really the case if you go deeper. And this is because of a few reasons. Like the first major reason is that there is really no separate kernel, and some entities in kernel are namespaced, but some of them are not. So of course, containers are taking advantage of the fact that kernel is namespacing file systems, mounts, that it's namespacing PID and so on, but not everything in kernel is namespaced. So if you are a root in the container and you go into sys directories or proxies or proc_irq, you still can see some stuff from the host. And you can even go deeper and access more stuff from the host system if you are running privileged containers, because that's also the thing. And container runtimes and container engines give you so much flexibility about what you can mount that from the host that it's very often not so hard to break out from the container. And what I mean by breaking out from the container, here is like the most radical example, what I mean by that. So pretty much like what you see here, which is what currently works on every distro which doesn't have SELinux enabled. You are just a regular user with the access to Docker socket. You spawn the privileged container with /directory mounted somewhere inside. You can chroot to it, and then boom, you can do pretty much everything on the host. So yeah, sometimes containers do not contain really. And like from my understanding and like my main theory why we even allowed to let this happen, and yeah, why we ended up with so much flexibility, and like we kind of like maybe gave up on concept of isolation as we had this in VM, is that we in container words we somehow got used to not having a boundary between infrastructure and workloads, because during the era of VMs in OpenStack, let's say early OpenStack, there was a huge boundary between workload, so the VM, which was containing applications, and infra, which was usually deployed by something external. So like traditional VM infra was deployed by, let's say, Puppet, Chef, or whatever. And then applications were running inside VMs, which were managed by that infrastructure as a service cloud. But nowadays, in the container era, for the convenience and for making the life of DevOps engineers or sysadmins easier, we kind of agreed to not have such a strong boundary between those. So in Kubernetes, pretty much the only non-containerized component is kubelet. Everything is running as a container. Even networking plugins are running as containers. So those containers have to be privileged. Those containers have to access stuff on the hosts. And during the libvirt times, it would be something unimaginable to, for example, run open vSwitch inside a VM and somehow expose it as a part of infrastructure. But nowadays in Kubernetes, we even require to run CNI plugins, for example, as a part of infra. And don't get me wrong, I'm not against it. It's very convenient. It makes deployments easier, but at the same time, it gives us a challenge about security, and we need to think about security even more, because we have that case when we have to kind of like differentiate between privileged containers which can do more, and like differentiating them from like regular containers which are running applications. And like there were some attempts already to tackle this problem, and I think that SE Linux went the most farther, because like SE Linux is pretty much the only LSM which doesn't allow you to do that. But on the other hand, we all know how SE Linux is. The most of us disable it, me too, very often in many cases. But honestly, like SE Linux so far is the only like Linux security module in which you explicitly need to agree on what directories you are allowing to mount inside containers. But of course, SE Linux is not easy to use. It's annoying, and it's kind of also like a legacy technology, because like when you look at SE Linux configs, it's like mostly designed for traditional applications running on hosts. It's quite hard to use, because like when you do SE Linux, you pretty much need to write policies and do configuration through text files. Not really fun experience, right? So that's why lockc comes as a project which is trying to tackle that problem of container security and container policies in some like different way. But first things first, let's look at how Kubernetes currently wants to tackle the container security issue. So we used to have PSPs, but I'm not going to talk about them because they are already deprecated. Nowadays, the KIP, which was just like quite recently, around 1-2 months ago, merged, and now it's during implementation. Nowadays in Kubernetes, there is an idea of having policies. There will be like 3 main of them, which will be predefined and hard-coded in the admission controller, which is gonna be a part of Kubernetes code base. So there will be privileged containers, baseline containers, and restricted containers. And currently the idea is that those policies, like the fact which policy applies to which container, will be defined on Kubernetes namespaces. So there is gonna be a Kubernetes namespace label to which operators will apply a value, either privileged, baseline, or restricted. If there will be no label, no policy label on the Kubernetes namespace, the baseline will be the default one. And like overall, it's a great initiative. I really wish the best for it, but there is a tendency in container world that all the burden of handling security is moved to Kubernetes, so the high-level clustered API, but there is not really a concept of policies or like security in the runtimes themselves on the host. And in my opinion, that's a hole which we need to maybe cover and like make some projects to handle security policies on a host runtime level as well. Why? Because when you containerize some application, you firstly test it on a laptop locally, right? So in my opinion, it would be very convenient, even for Kubernetes users, to be able to test out some policies even on the host and to be able to like differentiate containers in terms of security, even locally with Docker or Podman. But on the other hand, such a project could tackle also the use case where people are running some containerized workloads, but they are not running on such a huge scale that they already need Kubernetes. Like there are plenty of people who use some kind of like, yeah, they use few servers on which they just run Docker and Podman, and having some kind of security policy engine could be convenient for them as well. So yeah, I think that's like having some kind of security policy management on host runtime level is something which is needed too. And that's where lockc comes in. And lockc will, the idea of lockc is to apply policies on host runtimes, regardless whether we are using some container engine on host directly or whether we are using Kubernetes. And in case of using Kubernetes, the assumption would be to use exactly the same policy which is applied by Kubernetes API. And that would require also having some kind of parity in between Kubernetes policies and lockc policies, which would be enforced on the host level. So yeah, the current goal for the project, it's still in very early stage. It's still an experiment, and like I started it 1.5 months ago or something like that. It's still very early stage, but the goal for now is to define policies like they are described in that KEP, which was recently merged. The goal would be to apply baseline policy by default. The goal would be to also like apply privileged policies on kube-system containers to not prevent Kubernetes from running itself, because like when we deploy Kubernetes, of course, all the first containers like API server, scheduler manager, and so on, they have to run flawlessly. But the goal would be also that if there is no Kubernetes and some container workload is coming from a local container engine, then we would allow to apply a privileged policy only if it's a container which is spawned by the root user. And I would imagine here also checking whether, in case of Docker, checking whether root requested it from the Docker socket. But also, of course, everyone, even user and even on a rootless container, would be able to apply a restricted policy. And restricted policy would be something more strict than the default baseline policy. And I would imagine that restricted policy would be used for the app which we don't trust fully, or like we want to like really isolate even more than a regular container app. But yeah, that's the brief idea how what lockc should aim for in the nearest short term, like let's say in the nearest few months. What's yet unsure from my side is whether we'll ever implement any more custom policies and whether we'll allow somehow users to define their own policies, and if yes, how, whether we would come up with some, I don't know, ability to define policies through YAML files and somehow translate it, or whether they would have to be written as programs. That's not sure for me yet. I'm open for suggestions. And so we are talking about this sometimes with Darren, but yeah, like both of us are still not sure like what would be answer for that first question. And yeah, like still one open area for me is having some mechanism of making sure that Kubernetes annotations which we receive on RunC really come from Kubernetes, because so far it's just like when we start some RunC container, we receive annotations as a JSON, but there's not really a validation whether it really came from Kubernetes or not. So I would like to in future avoid situations where someone would just run some container with RunC and type the annotations manually and then somehow bypass our security mechanism. So that's an open topic where I'm trying to think of some solutions as well. And the current implementation, I will start from technology. So the main technology behind lockc for now is LSM plus BPF, which is sometimes called also KRSI, kernel security instrumentation. I guess that the most of you are already familiar, at least briefly, with what eBPF is. And since kernel 5.7, there is a feature of writing BPF programs which attach to LSM hooks in the kernel. So LSM hooks are hooks in the many places of the source code is on kernel source code, and LSM is in general a foundation of like all security plugins. So on SE Linux, AppArmor, Tomoyo, and whichever Linux security module you know is based on LSM. So LSM is foundation of them all. And now there is also a possibility of writing your own BPF programs which are attached to LSM hooks. And when they receive the LSM hook, those BPF programs are able to decide whether they allow or deny some action. So that's the mechanism which lockc is aiming to use for implementing those policies on containers which are mentioned about. But for user space parts, so for the loader, for all the infra around BPF programs, I'm using Rust. But for BPF programs themselves, I still have to use C. And speaking about architecture and components, so far in lockc there are like three kinds of components. Like there are those BPF programs which do actual policy enforcement. There is lockcd, which is a loader of BPF programs, and in near future, even like in next weeks and hopefully before next demo, it's gonna also handle the lock collection. And there is a lockc runc wrapper, which wraps the runc, and before executing runc, it registers the information that a new container is starting in BPF maps. So then BPF programs can track all the children of runc, and so they can track all the containerized processes and register them. And yeah, like that lockc runc wrapper is the first element which makes BPF programs aware that, oh, okay, there is a new containerized process and a new container. And then BPF programs themselves are registering all the children of runc and all the children of like the main endpoint of container. So the post factum tracking of new processes is done entirely in BPF programs, but like the first registration of container happens in that runc wrapper. Here's a diagram which shows that architecture. So yeah, as I mentioned, here's that lockc runc wrapper which registers the container. And then every child of lockc runc wrapper is monitored by two BPF programs, scat process fork and task alloc. Those two BPF programs, they receive every process creation event in the kernel. So they are monitoring all the clone and fork calls in this system. But on every clone operation, they are checking whether the parent of the new process is already registered as a container in BPF maps. And if yes, then the new process is also signed as containerized, and then it goes deeper. Like if there is any new child of a process which is already considered as containerized, as belonging to some container, it will be signed too. And then there are a bunch of BPF programs which are handling applying the actual policy, and they are triggered by LSM hooks. Important thing here is that yes, like in every LSM BPF program, you are able to look up in context of which process you are. So in each LSM program, we are firstly checking which process we are in, and then we are checking whether that process is containerized. And then if yes, we can check to which container it belongs and what kind of policy that container has. Here, I think I'll show a small demo. I have two small demos. The first demo is made without Kubernetes, and the second one is involving Kubernetes already. The first demo is just a simple example with Podman and a simple policy of not allowing containers to read kernel logs. Because by default, when you run Podman, you can do dmask and you can look up for all the kernel logs on the host. Before we spawn any container, we firstly check whether, this is still the demo which I recorded before changing the name of the project. Sorry for that. So here it's still Enclave, not lockc. But yeah, for now, when we ran Podman without the runtime wrapper, the container still didn't got registered. But now, in that comment here, we are picking the lockc runtime wrapper, or in that case, Enclave runtime wrapper as a runtime for Podman. And now we can see that that new container got registered in a BPF map. So we have a BPF map entry about the container where the key is like the, And we can see now that with that container which got spawned with the Enclave runtime wrapper, we were not able to read the kernel logs. So that was the first demo. The second demo is with Kubernetes, and which will briefly show how we are able to apply different policies for different Kubernetes spots. But unfortunately, I need to make you aware that there will be 2 bugs visible on the demo, which I'm really sorry for, and hopefully I'll get them fixed for the next time. So the first thing is that unfortunately with lockc, I have a bug that the containers cannot be executed. So you are not really able to do container exec or like cryo exec or docker exec anything. And that's why the Cilium pod is crashing, because it has post init and pre-start hooks which require executing the container. I still need to get it sorted and get it fixed. But anyway, we'll see on the demo that like all the containers which managed to run, they got registered in BPF map. They got the privileged policy, because they are, so far we have only kube system containers. We have only the Kubernetes infra spawned. But now we are gonna deploy the Nginx deployment. So let's do that. We apply the Nginx deployment, they are running. Okay, yeah, like there's still a crash of core DNS, and but Nginx is running. And when we go to the next terminal, we'll be able to see that there is a baseline policy applied. The another bug here, which is visible, is that there are two Nginx pods, but for some reason, like the containers with baseline level, policy level, they got registered 4 times. And I noticed that there is sometimes that bug that like some containers are getting registered twice. There is also something which I have to fix. But yeah, that was pretty much it from demos. And my next 4 items for the future will be testing, because it wasn't done so far. I didn't really make any integration tests. There are not so many unit tests yet. And of course, I need to fix some bugs, and you already seen 2 of them there. Also, the another next work item would be making deployments easier, because the current Vagrant file is a beast, and I'm having quite some trouble with Vagrant so far. For example, yeah, I have to, when provisioning Vagrant VMs, I have to do a reboot, because I'm modifying the group config, and then I'm rebooting. I have to reboot to get some new kernel parameters, and like Vagrant is sometimes not fine with it. Like sometimes Vagrant is behaving weird when it restarts during provisioning. And I'm also looking for maybe trying Terraform and preparing the QCO image used by Terraform, provider libvirt, and provider VirtualBox by some guestfs tools for provisioning. Also, the next item will be blocking non-wrapped RunC processes, because on the first demo, you've seen that at the beginning, I could still execute Podman. Could still execute Podman, which was not wrapped by lockc runc wrapper, and I could still run some workloads which were not secured. My next work item would be using those BPF programs I already have to prevent some unwrapped runc processes from running. So like once lockc BPF programs would be loaded, all the unwrapped containers would be denied from running. And also so far, like, okay, I've showed on the second demo that there are different policies applied for Kubernetes workloads, but I didn't make a mechanism yet for doing it in local container engines yet. But hopefully that kind of feature will show up soon in the future.